In this video, we're going to look at functions, domain, range, and intercepts. Specifically, we're going to look at the domains and ranges of our parent functions that we've learned so far. So function, recall, is a relation between two or more quantities in which for every input there is only one possible output. It can be represented in a number of ways. So you can have a function that's represented graphically, right? You can also have a function that is represented algebraically, and you can also have a function that is represented numerically. We're going to take a look at parent functions, which are represented here graphically. So you can see right there, represented graphically. We're going to look at points on the parent function. And then we're going to look at domain and range in both set notation and interval notation. Okay, so let's start off with the first function that we learned. We learned this back in our first year of high school, and that is the linear function. All right, so how do we find points on the parent function? Well, students often think, do I have to memorize these points? And absolutely not. You can just really look at the function itself. So f of x is equal to x. So you can say y is equal to x. And you can create a table of values if you wanted. So you have x right here and you have y here. And you just pick your x values and find out what your y values would be from that. So if x is equal to 1, well, you look at the relationship, y is equal to x, so therefore y is equal to 1. If x is equal to 4, then y is equal to 4. If x is equal to negative 2, then y is equal to negative 2. If x is equal to 0, y is equal to 0. And there you go, you have points on your parent function. The domain and range in set notation would be as follows. Well, it could be any x values, so that we just say x is an element of all real numbers. And then for range, we would say y is an element of all real numbers, because if we look at this line, it could really just be any possible number. The domain and range in interval notation would be as follows. If x is an element of all real numbers, what we would simply say is that x could go from negative infinity all the way to positive infinity. And the range would be y is an element also from negative infinity to positive infinity. Great, that takes care of the first parent function, which is a linear function. Now let's take a look at the quadratic function. So this is the function that we learned the next year in our high school. So points on the parent function, we'll start with, say, for example, why don't we start with negative 2? Okay, so if we start with negative 2, we just take that negative 2. We can see right here that it's y is equal to x squared. So we take negative 2, we square it, we get 4. Okay, negative 1, square it, we get 1, 0, 0, 1, square it, 1, 2, and 4, so on and so forth. So now we've generated some points on the parent function. Again, we didn't memorize them, we generated them using the equation of the quadratic parent function. Take a second, see if you can come up with the domain and range in both set notation and interval notation. You just hit pause and try it out for yourself, and then when you come back, the answer should be up for you. Okay, and there we have it. The domain is x is an element of real numbers, y is an element of real numbers, where y could be greater than 0 or equal to 0. And then we have the domain and range stated in interval notation. Next one that we're looking at is the square root function right here. Again, you can come up with xy values that are points on this parent function. So you just pick values of x that are perfect squares. That will make it easier for you. Otherwise, you're going to get these big irrational, like decimals, or these long irrational numbers. Okay, so what I mean by that is, like, what's a good one to start with? Well, when x is 0, the square root of 0 is 0. When x is 1, the square root of 1 is 1. Now, I'm not going to choose 2 because the square root of 2 is an irrational number, which means that it is an infinite and non-repeating decimal. So instead, what I'm going to do is I'm going to choose x is 4 because the square root of 4 is 2. And then the next one I'll say x is 9 and the square root of 9 is 3. Okay, take a look at the graph, see if you can come up with your own domain and range. Okay, and here you have it. The domain is x is an element of all real numbers, where x has to be greater or equal to 0. And y is an element of all real numbers, where y is greater or equal to 0. And then we have it also in interval notation. The next function we're going to look at is the reciprocal function. And this one sometimes gives students a bit of a challenge trying to generate points on the parent function. But what I'll say is you can actually make some really easy ones for yourself. So First of all, we have to state one thing. We can't have 0 in the denominator, so x can't be 0. All right? So we're going to restrict that value. All right, so now what I'm going to do is I'm going to pick some values of x and just take the reciprocal to find the y value. So let's start on the negative side right here. So if x is -2, the reciprocal of that is just -1/2. It still stays a negative. Taking the reciprocal doesn't change its sign. I'll go down to -1, or rather up in this case, -1, and then the reciprocal of -1 is just simply -1. And then what I'll do right here is I'll choose -1/2 as an x value because the reciprocal of -1/2 is just simply -2. And then I'll do some positive ones. Okay, well 2 is 1/2, 1 is 1, and 1/2 is simply 2. And there I have it. I've got some points on the parent function that would help me graph it if I needed to. Okay, as you can see right here, we have a restriction for the domain. I'm going to go ahead and write this one out. The restriction on the domain here is x is an element of all real numbers such that x cannot be equal to 0. For the range, y is an element of all real numbers such that y cannot be equal to 0, and y can't be equal to 0 because this fraction can never equal 0. And what I mean by this fraction is this fraction right here. Okay, y equals 1/x. This can never be equal to 0 because a fraction can only equal to 0 if the numerator is equal to 0. So, okay, this right here can never equal 0 since numerator is 1, right? So y, the reciprocal function, the y values of the reciprocal function can never equal 0 because it's a fraction, and therefore a fraction can only equal 0 if the numerator is equal to 0, and since the numerator is 1, that fraction is never going to equal to 0. All right, for the domain and range, we're going to have to use some union notation here because we will have x can go from -infinity all the way to 0. Oh, sorry, I'm using a curly bracket here. What I should be using right there is I should be using a curved bracket. Let's try this again. Domain is x is an element of -infinity to 0 in union with 0 to +infinity. Okay, and then range is y is an element of -infinity to 0 and 0 to infinity. Okay, the next one that we're looking at right here is the exponential function. Note that I've got some restrictions here stated for the exponential function for the base. So the base has to be, right here, I'll just quickly show you. Okay, the base a has to be greater than 0 and it can't be equal to 1. So you can't have a negative base and the base can't just be 1. Okay, so let's plug in some numbers right here to find some points on the parent function. Again, all you need to do, okay, we'll say right here if a is equal to, what we'll say if a is equal to 2, okay? Okay, if a is equal to 2, then we would have the following, and I'll put this over here. So if the base is 2 right here, we would say y is equal to 2 to the power of x. So if x is, let's say, -1, then this right here is 1/2 because a negative exponent produces a reciprocal. If x is 0, that's just simply 1. If x is 1, this is 2. If x is 2, that's 4. If x is 3, this is 8. Okay, so that right there would be if you have a base of 2. But what if we just keep it general? Well, if we were just to keep it general with a, we could say -1 would be 1/a. 0 would just be 1 because anything raised to the power of 0 is 1. If it's 1, that's simply a. If it's 2, that's a squared. And if it's 3, it's a cubed. I just did it here with an actual base, but this is with a general base A. All right, we look at the domain and range. See if you can come up with it on your own. One thing that you should probably notice is that there is no exponent on x. There's no exponent that would cause this to become equal to 0. So that should help you with your domain and range. Okay, and so here is our domain and range, and notice that the range is that y is always greater than 0, but it can never be equal to 0 because there is no x value or no exponent that would make that equal to 0. Okay, let's take a look at this cubic function. We just have the cubic function, the sine function, and the absolute value function to finish. So let's just start with the cubic function. Try and list off some points on your own and see if you can get the domain and range. You can press pause. When you come back, you should have the parent points and the domain and range listed. Okay, so as you can see here, I just picked -2, -1, 0, 1, and 2 on my parent points. And then what we did here is we then just took the -2 and we cubed it, so that would give me -8. -1 cubed is -1, 0 cubed is 0, so on and so forth. The domain and range is pretty straightforward. It's just XER and YER. Now for the sine function, you have to remember for sine function that the x inputs are degrees or radians. So I'm going to give you both here. So on the sine function, the points on the parent function, we start at 0, 0. Okay, so 0, 0. All right, so 0 degrees or 0, or alternatively 0 radians and 0. Then the next peak right here, this peak right there happens at 90 degrees. 90 degrees, and it goes up to 1. Alternatively, 90 degrees in radians is just simply pi over 2, and that's 1. Then it goes back down to 0 at 180 degrees, and 0. That's simply pi and 0. Then 270 degrees and -1. That's 3 pi over 2 and -1. And then back up at 360 and 0 right here, and that is 2 pi and 0. Okay, so those are the parent point, so the points on the parent function. You can see that, yeah, you can sort of recall that from previous years. Now what you should be able to do is take a look at this and write the domain and range. So let's go ahead and write that out. Okay, so the domain is XER, and the range is YER, but it only goes from -1 to 1. And if it's only going from -1 to 1, we have to make sure that when we do the interval notation that we're using square brackets. The last one is absolute value. And absolute value simply means that if you have a negative value, you just make it positive, okay? So you take that negative value, you multiply it by -1, it becomes positive. So for example, if I have a negative value like -2, I multiply by -1, I get 2. I have a negative value, multiply it by -1, I get 1. 0, 0, and then 1 is not a negative value, so I leave it alone, keep it positive. 2 is not a negative value, so it just stays. And these are our points on the parent function of the absolute value. So the absolute value says if you have a value that is negative, just take that value and multiply it by -1. Go ahead, see if you can come up with the domain and range yourself. Okay, and there we have it. There's our domain and range for the absolute value function. Just double check that you have it correct. The one restriction is on the y value, and the y values have to be greater or equal to 0. All right, final thing that we're going to look at in this video, we'll do it quickly, intercepts. To find the y-intercept, you have to set x is equal to 0 and solve for y. This is because the function crosses the y-axis when the value of x is equal to 0. X-intercept, to find the x-intercept, you set y is equal to 0 and solve for x, and that's because the function crosses the x-axis when the value of y is 0. Y-intercepts are typically easy to find. X-intercepts are a bit more challenging. So let's start with the y-intercept right here. They're typically easy to find because all you have to do is set x equal to 0. And you set x is equal to 0 because that's when it crosses, when x is equal to 0, that's when the function crosses the y-axis. All right, so let's go ahead and do that over here. We're going to set x equal to 0. And if I look at this function right here and I set x is equal to 0, well, that's going to eliminate the first term, the second term, and the third term. So I'm just going to have y is equal to 0 cubed plus 2, 0 squared, minus 0 plus 7. I'm just going to have y is equal to 7. Now, for my x-intercept, I'm going to have to set, so this was, let's just write right here, that's my y-intercept, okay? For my x-intercept, okay, I'm going to set y equal to 0, and then I've got this pretty complex cubic expression here that I have to solve for, and we don't have the tools to solve for that just yet. We will later, so all I'll say right here is just solve for x. Okay, so you wouldn't be expected to solve for x in this case right here because you don't quite have the tools. You're going to learn the tools to solve for that in the next unit. Okay, that's it for functions, domain and range, and intercepts. Thanks for watching.